Hi, welcome to video number 4 of the spaCy tutorial series. We're back! In the previous videos, we've been trying to find programming languages in sentences, and the way we've kind of been doing that is we said, we take some data, like the texts and that sort of thing, and then we have these rules. These rules were pretty good. Some of those rules made use of machine learning models, but these were rules that we came up with ourselves such that we can recognize programming languages. So you could say that we went from data to rules to labels. What I would like to do in this video is explain how to do something else. The idea is that we'll say, hey, we have labels and we have data. We give that to a model, and hopefully the model is then generating rules on our behalf such that we can automate this process a bit. I will argue that the approach we had before is not a bad one. It certainly has merits to it. It's quite easy to add a new rule, and it's also easy to understand. But maybe there's a couple of rules that we didn't come up with that are actually relevant. And that's kind of the idea behind machine learning in general. Hopefully, by giving labels and data, the model's going to be able to automate some of this stuff. That means that the goal for today is that we will end up with an NLP model that we've made ourselves. So the goal is to say, hey, give it some text, out comes a document, and inside of that document, there's going to be an entity that we'll be detecting. So I will take where we were before and explore this phenomenon on how we'll be able to get here. But again, the goal is to take our labels and our data and then have our own model. And in code, that means that this will be the end result of this video. We will need to train our own statistical model for that. So if I'm going to be making an NLP object that can detect programming languages as entities, I mean, that's super cool. But probably a good idea is to first kind of review what spaCy's doing internally. So what I've written down here is this NLP object. It's the basic one that comes with spaCy. It's the medium one from the web. And the goal is to I just wrote some text here that's gonna lure the NLP model to detect all sorts of entities. And I prepared this sentence because there's going to be lots of stuff detected, and one thing that you're going to see is I'm going to hit this one little render functionality, and what you're going to see here is essentially the document that we have here, but then all the different entities that are detected are just highlighted. So you can see that like Vincent, that's a person, that's correctly highlighted. 23rd of June, that's a date, that's I would argue correctly highlighted. What I found funny when I was playing with this, you can see that Google is an organization, there's money that's highlighted. But you do see there's like a couple of small mistakes in here. So like this dollar symbol might have been part of this money, and this cardinal number, I mean, I guess euro could also be attached there. And I think, like, I don't actually work for Google, but if I were to fill in Raza here and now run this again, you see that Raza is detected as a person. And there's a couple of things as well. I think if I do this lowercase, that then Vincent and Raza are no longer detected as names of people and such. So, okay, so there's definitely like a statistical model working here. There's not in no means a perfect method, but what you do see is that spaCy does have this NLP object that's able to do something with entities here. We see that the entities are visualized, and if we want to grab those entities, actually we can. So this doc object here that has this ents property. And what we can then do is we can loop over all the entities that are in that document. So I can say something like, hey, we have Vincent, we have the 23rd of June. Raza, in this case, it's detected as a person, so that's incorrect again, but it's being picked up. And another thing that we can verify real quick is that these entities that are in here, because they can be multiple, like a collection of tokens that follow each other, so to say, that's actually a span object. So those are not separate tokens. It's not a list of tokens or anything like that, but it's a separate spaCy object. It's a span. You can look, a span is kind of like a collection of tokens though, so you wouldn't be too wrong if you said that. but it cannot be any collection of tokens. The span that you have, the tokens have to be consecutive, like they have to follow up on one another. But yeah, these are entities, and this NLP call that we're doing with this giant string, that is causing all of these entities to be detected. So this NLP that we have here, it has the necessary logic in it to perform this task. So what I'm going to do now is I'm just going to dive a little bit deeper in there. Because if I have that NLP object there, what I think I'm able to do is there's this pipeline in there. And what the NLP object here essentially is doing is it's taking a sequence of steps after each other to change that string into this document that has all sorts of properties in there. And what you can see here is that there's actually like a couple of things in here, right? So the pipeline consists of 3 steps. We have this tagger, we have this parser, and we have this NER thing. Now this NER thing that's attached, that seems like it's the thing that's detecting all of these entities right here. But there's also some other steps in here, right? So we can kind of play with that. And again, I'm doing this very quickly to get a bit of an understanding. I don't want to spend too much time on it, because again, the goal is that I just make a pipeline that has programming language detection in it. So I figured it'd be good to just briefly check the documentation of spaCy. You can get here via usage and then processing pipelines, and then the first thing that you basically see. And this explains what's in this NLP object. And it's kind of what we saw before, right? So there's like some text that we've got, and then that text is going through this NLP object, and out comes a document. And these are sort of the pipeline steps that we then see. Now, there's this one part of the NLP pipeline that you got to do. You got to tokenize. If you don't tokenize your text, you're going to have a bad time. So that's not something that we can change. But then all the steps here that follow, these are things that you can sort of add or attach or set manually. So we've got our little tagger here. That's the part of the model that does the, hey, is it a noun, is it a verb, and then that sort of thing. And then we have this parser. What the parser does is it sort of says, hey, this I walk. Okay, between the word I and walk, there's a grammatical relationship. That's what the parser does. So those are the dependency labels. And then there is this named entity recognition bit, the stuff that's happening at the end here. And that's detecting and labeling these named entities. So that's the part where, in the previous example, Vincent was detected. So just to confirm my understanding there, I'm going to go back to the notebook and have a little bit of a play with that. So I'm back here at the notebook. For convenience sake, I copied the little diagram they had there. And what I have here now is this document, and there are these entities that are in there. And we can confirm that Vincent is one of the entities that is being detected here. But if I'm not mistaken, this pipeline thing... I think I'm able to remove a step from it. So is it something like remove pipe? Yeah, that's the one. And I think I can say, hey, let's just remove the NER bit. Let's just take that out and see what happens. Yeah, and if I now look at the pipeline in that NLP object... Right, so I remove the NER bit. And now if I give the same NLP object that one sentence, I think now Vincent is no longer detected. Right, okay, so definitely that NER part over there, that's the thing that's detecting the entities. So when I'm going to make my own pipeline, this is sort of the part that I gotta be making. This is the part that I gotta be sure that's in there. And actually, you might remember from like the first video, this NER bit is something we turned off manually. So when I was detecting Go, the programming language, the way I did that was I just had to know, is Go a verb? And I did some tricks with the dependency relationship as well. But then I removed this NER bit because that was slowing down the entire pipeline. So we've seen this pipeline sort of before, it's just now we're sort of explicitly playing with it. But what I'll be building now, with this understanding, is I'll just start with a fresh pipeline, and then I'll see if I can add a step that's going to detect the entities that I find interesting. So I'll be making a machine learning model, but the machine learning model I'll be making, that's something that's got to click onto an NLP object like so. But this helps me understand kind of the stuff that I'm dealing with and the stuff I got to be making. So I understand a lot of the pipeline stuff now, I guess. So then I figured I got to move on and go towards the machine learning bit. So again, I went to the docs, usage, NER, and there's a simple training loop here that's listed as an example. So I'm going to be trying to kind of learn from that. And actually, there's something interesting they're doing here. So apparently what you can do is you can start with a blank English NLP model, and instead of taking the pre-trained model and then replacing a pipeline part, what you can also just do is start with a blank one and then just put your pipeline steps in there as you wish. So this looks like a pretty cool example to work from. And what they have here is an example of some training data. Now, this training data in particular is about organizations, but this looks like something I can copy and adjust to my programming use case. And then what I also see is some stuff that has to do with an optimizer. So, okay, so this looks like a pretty cool starting point. The way that you're supposed to give training data, it seems, is that you can have a list of tuples, where the first thing in that tuple is just a string of text, and that you then give it a dictionary with stuff you want the model to learn. And in this particular case, I'll just limit myself to these entities, but there's an example annotation dictionary on the side here that suggests that you can also do other stuff. So yeah, there's like the tag stuff. So is it a verb? Is it a noun? That sort of thing you can also do. There's some dependency stuff. So what is the root? What is the subject of? And etc. What's also interesting is you can also do something with categories. So that means that you can say stuff like, oh, this entire sentence is about this one topic. So that's good to keep in the back of my mind. But for now, what I'll just do is I'll quickly just make a copy of this train data and just make an example sort of what the data that I am supposed to provide is sort of supposed to look like. So I kind of wrote that up here now. So I found the documentation and I kind of just copied the training data example that they had. And it says that Uber blew through $1 million. Okay, so then the Uber here is then the entity. And it seems that you're supposed to take the start and the end of where the entity is. So, okay. That means that for me, what I gotta do is I gotta do stuff like, okay, Python is cool, suppose that that's a sentence. Then I gotta make training data that kind of looks like this. And then Python is cool, me like Golang. Then, oh wait, and there's a mistake here. This is not an org, this needs to be a programming language. So, don't just copy and paste, always think. But this is then something that that I gotta be making. And as luck would have it, so I have this separate labeled text file that I had before. And I also have this matcher that I have. So what I can say is, and that's going to be useful here, if the labels say, hey, there is indeed a programming language in here, and the matcher in that label says, oh yeah, and here it is, then I can use the matcher from the previous video to start generating some training data. Which seems like a pretty good idea. So I'll grab the code from the previous lecture, and I'll start making just a long list with stuff like this in it. And then once I've got that, and I'll start worrying about the training loop that I gotta make. All right. So what I have done now, so I've got some code here, but I didn't feel like copying stuff into my notebook for the stuff I had from the previous lecture. So what I've done is I've made this common.py file here. And you might remember this code from the previous lecture. There's this create versioned function, and there's all these different patterns that I had before. But what I've essentially done is I've just said, look, there's these two functions, and I don't want to have these functions in my notebook, so I just have them in this common.py file, and I just import them like this. And it kind of keeps the notebook clean, which is something I like. I don't like to do miles of scrolling. But anyway, what I'm then doing now is I'm saying, okay, let's make our little matcher appear here. I've imported this above. And this is the same code as before. And what I can then do is I can run this, and just to confirm that it works, is I can say, hey, here's a document. I do code with data stuff using Python and Golang. Again, I loop over the index start and the end that this matcher is generating, and then I tell my document, hey, start here and there, and it's able to grab both Python and Golang. And also a thing to point out is technically that's a span that's being returned. It's not a separate token. Because again, what a matcher can do is it can say, hey, let's just not detect single tokens, let's take spans of tokens, so we can also detect things like Objective-C. So this is good to start with, but again, the goal is that I'm able to generate stuff that looks kind of like this. So I need to give it, I need to make a function that just accepts text like this and outputs a tuple that kind of looks like this big thing here. So what I've done is I've made this little function. It's called parse train data, and basically what it does, it does the stuff that we're doing here, but in such a way that when I run this, that the data format matches what we're supposed to generate. So if I give it the sentence I like Python, then I like Python is the string that we have in the tuple here first, and then it will say, but these are the entities that have been found. There's a long list comprehension in here, but essentially I'm using a matcher and I'm looping over it, and the style is very similar to what I'm doing here. And then here's just this tuple that says, hey, here's where the entity starts, here's where it's supposed to end, and here's the type of the entity. So let's now say that it's not just I like Python, but I can also do JavaScript and Golang, and start to run it this. Then it's not just this Python bit, which is here, but it's also JavaScript and Golang that are being detected, which is okay. So that's good. What I can now do is I can grab the labeled data set that I had before and have all the text pass through this, and this should give me my my training data set that I'm interested in. So what I've now done is I've actually made two changes. First, what I did is I added this code that we need to load in the data set that we had before. So this is the labeled data set. And what I'm doing is I'm just reading it in with pandas. And then I'm saying, look, where the label that we gave it says, yep, it's correct, then those are the rows we grab, and we grab this title column. So then, okay, this is for all intents and purposes, a list of strings that we want to parse. But what I've changed is I have this parse train data function, and before what we had was text went in here. But I noticed that was kind of slow. So and the reason is that we have this NLP.pipe mechanic that we have at our disposal, and it's great. We can just eat up all of these titles. But if we want to use that, then the function here needs to accept a document, not a bit of text. So that's a change I did here, which is a good habit. It's something we learned earlier. And then to keep it kind of easy, I just said, when the matcher just finds one thing, let's just take those and have that be our train data. And we seem to be getting our nice little list of tuples. So this is the string going in. And then we can tell our learning algorithm, hey, these are the entities that I want you to learn. And these are just some examples kind of at random, but it seems like it's being able to pick up that C++ bit there, the C++ bit here, and there's still the SQL Server stuff, but that's kind of okay for now. But this seems like the train data is set. So the next thing that I can do is I can make the training loop. And once that's done, then I can take my training loop and attach that to a pipeline. And then we're sort of full circle at that point. But we're getting there. We're almost there. So the stuff that I've just made is the stuff for this bit. So we have that training data. The next thing that I gotta do, what the documentation at least tells me, is that I gotta make this NLP model, and I gotta do this thing with the optimizer, and basically get this whole shebang running. And what I've done is I've pretty much copied this bit into the notebook, but I have made a bit of a change here on this one single line. I've done something a little bit different there. And the reason is that I want to make sure that the entities that I'm detecting, that they are indeed the programming languages and such, not per se this org. So I got to make sure that the NER part of this pipeline is aware of the labels that I'm interested in. So I just wrote a function to replace this one line. And the function looks like this. So it's called create blank NLP. And what goes in is the training data. Now, inside what I'm doing is I'm saying, hey, let's just create a blank NLP model. Let's also just create a named entity recognition step in the pipeline. Next, what I'm saying is take that thing we've added to the pipeline and make sure that it's attached to this NLP object. Note that I'm also making sure that we've added that last. And then what I do is I loop over all of my training examples, and I just make sure that this proglang entity that I've created up here, that this named entity step is aware of that. Because if I don't do this step, then the pipeline is not going to train very well. So with that out of the way, then here's the code that's actually currently running, because it takes a while. But here's the code that's currently running the train loop. And again, this is the stuff that you're going to find on the documentation page as well. But what I'm doing is I'm saying, hey, let's create a blank NLP object using the train data. And then what I'm doing is I'm shuffling over the train data. So I'm taking the train data and shuffling it around. And I'm doing that 20 times, by the way. And then for all the items that we have, I tell my NLP model, hey, could you just go ahead and update? And here's the text, here's the annotations, here's the optimizer that I'm using, which is just imported from spaCy. And here's the losses object. And what it's then able to do is I'm able to say, hey, here's some losses, and I would like you to print those. So here you can see that as this thing is training, the losses at iteration 0 that came in at this time step, and this is the loss that I have for the named entity recognition task. And what you can see is as time moves on, the loss is getting lower and lower and lower. And internally, there's a whole bunch of deep learning that's happening here. Don't want to go into the architecture there, but it's pretty much taking the text that we have, and internally it's learning using an optimizer, saying stuff like, hey, the model makes certain types of mistakes. Let's see if we can correct for that. And all that logic is essentially handled for us in this for loop scenario here. So I'm gonna let this run for a bit. Click pause on the record, and then when it's done, I'll come back. All right. So the thing is done, and I'm happy that I added this timestamp here. And in general, there's a few things that are worth probably pointing out. I mean, we see the loss going down over time, so that's a good thing, right? But there is one thing that I'm a little bit concerned about, and that is the amount of time it takes. This is 20 iterations, like 1,000 data points, I think, and it takes about 8 minutes, so it's not dreadfully unbearingly slow or anything like that, but it is, I gotta wait 8 minutes, it's kind of long. And also, if you look at this loop, what I'm essentially doing here is I'm saying, shuffle all the training data sets, and then after that's shuffled, take one example at a time and give that to the update rule here. So one example at a time will it learn and update. So that's a whole lot of looping, and the deep learning algorithms have gotten a little bit better. So what you can do is you can, make use of slightly better CPU instructions if you just batch these things together. So what I'm doing here is just slightly stupid. What might be better is that I don't give it like one example at a time and update, but maybe I can make some changes to this loop such that we are batching here instead of just giving it a singleton. And there's also some other settings, so what I've just done is had a brief look at the documentation that makes stuff just slightly nicer, and I've updated the train loop and run it again. There are three things mainly that are, I think it's three things, but there's a few things mainly that are different. For starters, what I'm doing here is I'm saying, let's mini batch this. So take this entire training data, and then the goal is that we're going to start out small, so we're going to have batches of like 4 examples at a time. And then as time moves on, we're going to be growing that and growing that and growing that, making these batches bigger and bigger and bigger. Now, there's kind of 2 reasons to do that. For one, it makes the training loop a little bit faster, but there's also kind of this regularization effect if you think about it. So to explain why this compounding thing is actually good for regularization, it's kind of a nerdy sidestep, but you might be able to imagine if there's a gradient that's sort of figuring out where to go. I mean, in the beginning, it just has to sort of move in a general direction, just like the mountain's sort of over there. But as you're climbing the mountain, you kind of want to be a bit more strict, perhaps, in how you're going to do your next climbing step. And then basing that direction on more examples than just a few, that kind of makes sense. So having this compounding batch is actually kind of a nifty trick that you can do to keep the learning a bit stable. So that's the main thing that I've added here. That's the main change. And the next thing I've done is I've also added some dropout, which is also meant for regularization. It makes it harder for the algorithm to sort of do catastrophic remembering, so to say. Because you want to generalize, so that's what dropout is for as well. Anyway, the main thing that we see here is, again, the NER sort of goes down, which is definitely kind of nice, and it stays at a small number. But the main benefit is the speed. This is taking like half the time, if not less. And what I also like to see in this NER step, a little bit less here, is if you go to the previous one, you kind of see that it's going down a bit, and then the loss is very small, and then somehow it sort of makes a wrong step, and it sort of escapes the optima, but then but the loss that I end with here is kind of high. While if you look here, it seems to be a bit more stable. I don't know if it's fair to fully attribute that to all the settings that I've gotten here. It might have also gotten a little bit lucky, but this is kind of nice. This is a nicer setting, definitely to be in. But here's the thing. So we've trained our model here, but the end goal is that we would have something like this, that we can say, hey, NLP, if I were to now check the pipeline, we now have, because we started with a blank pipeline, we now have a pipeline where there's only this NER part in it. So that might mean that if I were to give it a sentence like, I write code in Python, so I have this document here. So now if I take the spaCy and call render, and I say the style that it's supposed to do is the entities, or ent, boom. I write code in Python, and Python has just been detected as a programming language. Sweet. Nice. So that means that we can almost wrap up this video, because the goal that I had for this video was just to get this whole training loop thing right. Like, the thing we're going to have to do now is properly evaluate this, because there's still plenty of stuff that could be going wrong. But I am happy with the approach. The nice thing about this setup right here is when I have a training data set and and I add new entities to it, then I can kind of use this for loop here as a good starting point. And I've got all sorts of settings that I can slightly tweak, like this compounding thing and this dropout thing, to sort of experiment a bit with generalization. So in the next video, what I'll probably do is I'll start with this as a starting point, and then I'm going to be doing some strict evaluations from the notebook, making sure nothing's going wrong, and trying to figure out how well this is actually sort of working. But this is nice. Like we've trained our own statistical model here, so that's pretty cool. So where are we now? Well, we did it. We took our labels and our data, and we created a model that now has internal rules that will allow us to make predictions. It's kind of hard to understand this model, and we've not really taken an effort to, so that is something that we still need to do. However, in this video, we reviewed the pipeline part of spaCy, and we now have our own NLP model with our own named entity recognition step. We've got a training loop, and we can learn from more data, so if we label some more, we'll be able to use the same code, which is also a nice feeling. We are not done though, because if you think about it, this is where we currently are. But unfortunately, this is also where we currently are. This model, well, is never really going to be perfect, but I don't know if it's any good at all yet. And just like before, taking a moment to seriously evaluate what we got here, that's a pretty good idea, so we should go ahead and do that. So up next, we're going to benchmark this result properly and understand where it fails. If we understand where it fails, we might be able to improve it from there. So maybe we will be doing some extra labeling, maybe we will tweak some settings during the learning step, but this is stuff that we'll explore. See you next time.